Aloha Algebra 1 students. Today we're talking about line of best fit. So this is what our table of contents should look like if it's all filled out. If you have not filled yours out, please get it filled out. This is the graphic organizer that we're going to be using today, line of best fit. You need a calculator, a straight edge, a pencil, and 4 different highlighters. Please gather those supplies and let's get started. So as you can see, this is the same graphic organizer that you have. My graph is just a little bigger and put to the left, and then the context that's on your graphic organizer for me is to the right. Okay, so we talked a little bit about line of best fit on Friday, where we drew a line through the center of the data. Now, when we're talking about line of best fit, it's going to be a few more things. So let's just analyze the data for a second. And before we get started, I just want you to take a look at the labels. We have temperature in Celsius and sales in money. And I've added a break down here on the x-axis because this scale break starts at 10. And remember that our axis has to start at 0 because we know that this goes by 2, 4, 6, or 10, 12, 14, 16, 18. We can see that this is not the same going from 0 to 10 and then by 2. So I'm going to add in a break. So go ahead and add in a scale break there. And if you're looking at the y-axis, it goes 0, 100, 100, 200, 200, 300. We don't need a scale break there. So just on the x-axis. Okay, take your first color. Let's highlight, analyze the trends in data. And we talked about a couple things. Number one, we want to see, does our data go in a positive direction or a negative direction? And it goes for us in a positive direction, meaning as the x is going higher and higher and higher, the y is also going higher. And so we have a positive trend in data. The second thing we're looking at is there any distinctions in the data? We might be able to say, here's a cluster, here's a cluster, here's a cluster. So we might want to see here's a cluster of data, but because they're kind of spread out, I'm going to say there's no clusters. And lastly is this approximately linear? Now we know that this is not a straight line, but could it kind of look like a straight line? Yes, it could kind of look like a straight line. So we're going to say it's approximately linear. And because it's approximately linear, we can draw an LOBF, or our line of best fit. When we drew our line of best fit on Friday, we just said it went through the center of the data, or a place where it was very close to all of the data. So get your second color. Let's highlight, draw an LOBF, and take your straight edge. Let's draw a line through the center of all of the data that's there. Now, I'm going to line up my straight edge here. And there we go. Here is my line of best fit. So as you can see, my line of best fit actually hits 0, 100 on the y-axis. And it goes through 1, 2, 3, 4, 5 pieces of data. And then the other pieces of data are very close to it. So we have a piece of data there, very close there, very close there. So through the center of the data or close to all of the data. Okay, number 3, take your second color. And we're going to be doing a couple things. We're going to first be finding the slope, and then we're going to be finding the y-intercept. So we know how to do this from a graph, and we know how to do this from 2 points. We know how to do it from a table. We know how to find it, what else? Oh, in an equation. And because we really only have a graph, that's what we're going to be using. We have graph and we have data. So we're using it from like a graph and a table. So first I'm going to find the slope. Now I know that I have, like, none of these are hitting kind of here. And so in order for us to find the slope, we actually have to use two points that are crossing through the line. I'm going to use this point here, which is about, I'd say, 16.5 and 320. And maybe this point up here, which is about 25 and 600. Again, we're just approximating. We're not given actual data, so we just have to approximate where we think it is. From here, I'm going to use the table form to find the slope. So from 320 to 600, it's an increase of 280. From 16.5 to 25, it's an increase of 8.5. I know that if I go the difference of y over the difference of x, I'm going to get 32.9. So I have a slope of about 33. Again, a slope of about 33. Okay, so we also know that it says approximate b from the graph or use 2 points to find b. So because I have 2 points, I can find b this way. But let's look at the graph and let's say, can I approximate the y-intercept from the graph? And as we're looking here, it does cross through 100, but does it cross through the y-axis? This is really 10, so we're going to say no, it is not the y-axis, because the y-axis would actually be 0. And this is from 10, 100, so since we cannot approximate from the graph, we have to use the 2-point method. 2-point method, just a reminder, is when we take y equals mx plus b, and we plug all those parts in. Here we have a y, 600, 600. Here's our m, 32.9, 32.9. Here's our x, 25, 25. We're going to solve the equation for b just by using math. And so we're going to get a b of about negative 223.5. Now, as we're looking at this graph, we know that we're pretty much right, because at 10, if it's at 100, it has to be below that for 0. And so we know for sure that we're below 100, so we're okay. Okay, so we found our m from 2 points. Then we found our slope from our slope and 2 points. And the last thing we're going to do is we're going to create an equation for the LOBF, or our line of best fit. So this line here that I drew is going to be a slope of 32.9 with a y-intercept of negative 223.5. So take our m, take our b, and let's plug it into an equation. Okay, so again, number 1, we analyze the trend in data. Number 2, we drew our LOBF. Number 3, we found the slope and the y-intercept using the points from the graph. And then once we found our m and our b, we created our equation for the line of best fit, or the LOBF. Okay, if you have any questions or concerns, please make sure you come in and ask. Have an awesome day. Thanks.